Alrighty. Welcome everybody. Gotta fade that nice and slow, right? Nice. I had it like on in the background real low one time, and someone said it like someone was cutting in and out, so can't have any actual background music. So, but it's okay. All right. Welcome to week 6. Holy cow, we are flying by here. I kept my bracelets on just for the pity. So nothing's been graded. My apologies, but I was at the hospital. I promise. I have a bracelet. I'm not doing well. So it's been a real shitty winter, but we'll get there, and we'll keep moving on. So I got more doctor's appointments, and maybe they can make me feel better. So I'm looking forward to that. In the meantime, we still have more C# to work on. Should be a lot of fun. Again, we're finishing up the core of this is what C# does, finishing up the player's guide this week and next week, all the advanced topics. And then we'll take a week off for the midterm. We don't need a whole week off for the midterm, but it's okay. It's meant to be, easy is the wrong word, but doable. Maybe doable, right? That's the goal. It's not meant to be hard at all. I think exams are stupid, but I mostly have to have them. And then we'll take winter break, and then we'll come back in March, move on to some other cool stuff. So we'll look at database programming, specific data handling, spend 2 weeks on that, do our last project on data handling here, build a little database project. And then we'll move into the Universal Windows Platform that we can actually get to run on Xbox. So once we get to Universal Windows Platform, I probably just have to bring one here. I have to figure that out yet because we don't all fit in the lab, which is unfortunate. But we'll see how that goes, and we'll start talking about XAML. So we did a really quick XAML demo back when we did forms. We'll spend more time on XAML. Then we'll look specifically at graphics, and we'll look at some game building concepts and how we can design our code the right way to work with our games. Week 15 is just your time to work with the group because sometimes it's hard to get together. Ideally, at the end of this night, you're about done because you have other finals and other things going on. If you can get your game knocked out by then, you'll have an easy finals week because all we do on our finals slot here, 6:30 p.m. on 4/20, is we play our games. So each team will just get up and play their game. Maybe here I have to see because we don't all fit in the lab. I don't know. I don't know why we have a lab that doesn't fit 40, 50 people. But okay, I didn't design the new engineering lab building, so they didn't ask me. Go figure. So we'll figure all that out. We'll make sure we have an Xbox somewhere we can play on. I think we can just HDMI. Yeah, we can just HDMI to the projector if we have to. We'll make that work. So that'll be all of March and April, or I guess this back into March and April. We'll be building our games on Xbox, and this one is a group project. The other ones have been optional to work with a group. This one you must work in a group. Right? That's one of the outcomes here is that you can do group work and work together. So hopefully with your optional chances to work with people, you get to know each other. I don't assign groups because that's a bunch of work I don't want to have to do, and you folks know each other better than I do. So find people to work with, get to know each other. It'll go great. Generally, everyone in the group gets the same score unless someone just did absolutely nothing. Right? There is a partner eval that goes into scoring. Almost all the time, it's like my partners were great. Almost all the time. If your partner's not great, I think I mentioned this already, you need to tell them. Don't tell me that they're not great. Tell them that they're not great and not doing the things that you've asked them to do. Okay? If they become a problem, then we'll after you've had that conversation with them and they're still not following up on their things, then I'm happy to talk with you. Right? And I'll address it. But you need to tell them if they suck because sometimes people just don't know that they suck, which is, I don't know. Sometimes it's hard to be self-aware. But I have a deadline to meet this. I have to get my part in by this date. If I don't do that, that's doesn't go well. So generally, everyone gets the same score because you folks are all adults and know how to work together. It's not too bad, I promise. So, and then that should be a lot of fun. Unfortunately, we just play the games, have some fun, and then get out of there. So aiming for it to be a low-stress finals for this course here. Again, if it's not done by then, you've got some time to work on it here, but I know you'll have other lives and other classes and other things going on. So if you can get it knocked out on the 13th, best. If not, it's up to you, however you folks want to work on that. So we'll introduce it week 12. Again, we need some of the graphic stuff. The game building is nice design things that make it a little easier to accomplish. So it's a little weird that we're starting a project that you don't really have all the experience with, but that's okay. And it seems like a lot of you folks have already taken the game design courses, so you're going to be super bored when I talk to you because you've done it like a whole semester of this stuff. But the track, because you don't have to do this one first, it's I don't know. We're making do with the best we can. So, oh, I forgot to get chat here. Where is that on my other screen? There it goes. Did I miss anything? Oh my goodness. Yeah. Oh, thanks, Fluffy. Yeah, I'm working on getting better, so we'll see what the doctor says. Hey, Dodo. Thanks for dropping by. Yeah, we are. I've got a face-to-face class here, Dodo, but I like the hybrid stuff. All right, so for Player's Guide, advanced stuff. Oh, yeah. I'm sorry?
For project 3, were we supposed to get 2 or 3 weeks?
2 weeks. Yeah. Because that way it's done and out of the way by this week, so you have nothing before the midterm. Yeah. Do you think you'll need more time?
No,
on it?
okay. I remember over here 3 weeks, and I saw a due date. Not on it.
Okay, I think I said 2 for the Texas Hold'em project. I mean, if you need a third week, I'm open to that. I don't know, up to you folks.
I mean, so the third week?
Then it would be due the week of the midterm, and
I mean,
it's okay.
I mean, I wouldn't mind, honestly. That's not a possibility.
Sure, I mean, it's fine. I don't have plans to be here that week to like write the solution and show it. I could record a video. Is that lame? That's kind of lame.
I mean,
I could show up, but like you guys don't want to show up because you don't have to for the midterm.
okay, because the midterm's on campus.
Yeah, the midterm's just on campus.
Do the common class?
No, I don't want to sit and watch people take tests.
No,
No, that's
because that right.
some people like to sit and watch you take tests. I don't. So I mean, the programming is a much different kind of material. So you know, I don't know. That's okay. Hey, Wolfmaster, thanks so much for donating your Twitch Prime sub to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. Yeah, midterms. There's just a final project, no final exam. Lotus or Louts.
I think we, is it like only one player to play, right? Because you go against the computer, which we do.
No, 2 players. So
each player has his own deck of cards that you can see, or
so each player gets 2 cards in their hand. So player 1 and player 2, they each get 2 cards, and then there's the 5 share cards in the middle.
And so when it switches turn, like when we show on the screen that the different players can.
You can just show them both. I mean, it's not the best game. We're just trying to apply some of the concepts we've used and do some of this interesting stuff and use some of the stuff from the chapter. Making a computer make decisions. The goal is if we write this correctly and we use good object-oriented design, one of the things you can do without too much more code is say, okay, I know what my 2 cards are. I know what those 5 cards are, or at any level of this combinations here. What possible hands could you have? And then how often does my hand beat your hand? Without even like looking it up in a database, we can just calculate it by generating every single possibility. Now, there's a lot of possibilities when you have less cards on the board. When you get to 5 cards on the board, there's 990 possible 2-card hands your opponent could have. You can calculate 990 possible Hold'em hands, and for each of those Hold'em hands, find the best of 21 poker hands, and then see how often of those 990 possible hands do you win, lose, and draw, and your computer can decide, hey, I win more often, or I lose more often, I should fold or I should bet. So eventually we can get there to make a slightly intelligent computer that's not just doing random stuff. But for now, it's just fine. It's just the person sitting here gets to click the button, bet or fold or bet or check or whatever, and we just alternate who's the active bettor. It's trying to take some of the extra stuff that actually happens in the real game out because it's complex to just do like a stripped out version of it. It's just meant for some practice to get you writing some C#, have some fun with it maybe. Maybe fun's the wrong word, but something interesting maybe. Is that another question? I'm sorry. Yeah. So in our version here, each player at the start bets $1, and then you get your 2 cards. The way that it works in the real game is a little bit different, more complex. We only have 2 people, so it doesn't matter all that much anyway. Because usually you have like 10 people at a time playing, and other things happen. Okay, so let's go edit this one. We can push it out. I'm fine with that. If you folks need a little more time, it's not like I've got anything in on time anyway, so that's perfectly fair. It'll be the 23rd. Do that. Yeah, sure. Maybe I just do a video for it. I don't know. I'll see. I'll see how it goes. Yeah, sure. We can do that. Should be fine. Yeah, so each player starts with $100. You get your 2 cards, and then this round of betting. So we're going to alternate who is the active bettor. Again, this is not how it really works, but there's like 3 rounds of betting in each hand, and different people can do a bunch of stuff, and that gets a little more complex. So you either, if you're the active bettor, you bet or check. Check means you don't want to bet, you just want the next card. If you bet, then the other person has to match your bet or call it, or they fold and just give up and they take the money, and then we'll switch who's the active bettor. Between player 1 and player 2. So you get 3 cards the first time if there's a call, you get a 4th card if there's a call, you get a 5th card if there's a call, and then last round of betting, and then you actually see who wins. So there's the initial $1 bet, and then there's a round of betting with your 2 cards, nothing on the table. There's a round of betting with your 2 cards, 3 cards on the table, a round of betting with your 2 cards, 4 cards on the table, and a round of betting with 5 share cards on the table. And then you see who wins. So this idea with the hold'em hand is that you should be able to generate your best possible poker hand. So when I'm comparing, hey, is my hold'em hand better than your hold'em hand? To do that, my hold'em hand has to find its best 5-card poker hand. Their hold'em hand has to find its best 5-card poker hand, and then we compare the best poker hands, 5-card hands, to each other to see who's the better hold'em hand. So we kind of have to build on it. You need to have the 5-card hand poker hand class that is eye comparable, so we can see who's better, to be able to make hold'em hands comparable. Because we can't just look at 2 cards and say it's better, right? It depends on what's here. Does that make sense? Yes. So Fluminosity, the midterm is like half quiz questions, which I think I forgot to post a quiz. I'm going to blame being sick. Yeah, I forgot to post a quiz. So like half questions from the quizzes, and then 3 long answer style programming questions, shortish, not long, but long, like write some code to do something. Please use Visual Studio and copy paste. Do not write code in Canvas. That is not a tool for writing code. It is terrible. People still do it sometimes, and I'm really confused. Like, please just use your tool. And it'll be untimed, so just like the quizzes, the couple quizzes you had, you open it, come back to it anytime you want. As long as you get in by the due date, you're good. That's perfectly fine. Yeah.
I don't know like how or anything asking unless we have like obviously resources.
Yeah, please. Sure. Go for it. Yeah. Yeah, use your resources. No one, when you go get a job programming, is going to tell you to do it off the top of your head without looking anything up, because that's stupid. So I won't expect that either, because it doesn't matter what's in your head. It matters if you can actually do the stuff and do the work, right? You don't have to memorize it. No one can memorize all of it, right? And testing who has the better memory is not really a good test of who's a better programmer, or like if you are an effective programmer, or that sort of thing. It's a terrible measurement. And as I get older and my brain gets slower, I resent that more, because I had to take Calc 2 twice because I couldn't remember all the stupid formulas. And the one prof was like, "No, you don't get a note sheet." It's like, I just want my formulas. But that's okay. That's my problem, not yours. Some people have very different theories. That's the cool thing about education, is when they say I get to teach the class, I get to do basically whatever the hell I want, as long as I cover the right material. Which is kind of cool and a little weird, because then you get these like weird swings where some people are like, do everything on paper. And you're like, I just want to write code, and you get other people like me who just want to know you can write code. I don't care how you do it, just write the code. So it's a little weird. I'm sorry, and I'm sure it's going to feel weird for you as students too, as you find different people who teach different ways. But hopefully you get a good mix of that, and then through the big mix of everyone that you've had experiences with, you get something out of it. Hopefully more than just a piece of paper, because that's a big shame if the only thing you get out of it is a piece of paper, right? Okay, that was real philosophical, right? How'd we get there? You guys got to keep me on track. It is. Yeah. Sorry, give me just 1 second. Take my other liquids. Told you I'm not doing great. I'm not doing great. But that's okay. All right. So for the advanced stuff here, I don't think we'll get super far. I'm hoping to get through about files tonight. We'll see how well it goes. And then next week we'll get into the query expressions, asynchronous programming, because that's a pretty deep topic there. It's going to need more time. A lot of cool stuff we can do with asynchronous programming. We're not going to get into most of it, but even just to like get some of the basics down takes a little while. It's a very different way of thinking so far. So the managing larger programs, you folks can read that. Nothing super interesting here. For methods, there are all sorts of cool things we can do with methods. What is this? This is week 6, right? So we start up a new project. I'm just going to do a console app for right now. I don't want to do anything with. Oh, I guess we should do a forms. We should do a forms app. Why not? This is week 6, advanced part 1. So one of the things we've always told you about methods is that methods can only return a single value, right? And they're like, oh, haha, a single value could be a class with a bunch of attributes. They're like, okay, we got ways around that. So there's another cool thing you can do in C# because, right? Why else would we, not want to get around our silly rules here? No, that's not the right one. Sorry, on our form. Where's my form code? Goodness. View code. There we go. In here. So the other thing you can do in C# is you can have out variables that essentially pass things by reference. So like back to C++, passing things by reference was a fun thing. And then sometimes you have to use pointers, sometimes you use references, and it's a big headache. So generally, I frown on this sort of stuff because it confuses me here. But there's a couple of cool cases where we can do stuff like this. So you can write your own methods here that accept another variable. And by declaring, saying this is an out variable, it's going to get passed by reference, and then you can not return another value, but if you pass something by reference, you can change it and it stays changed. So you're effectively changing more than one value. You're still returning one thing, but you've done more cool stuff with it here. So just some silly little examples here. So void change number takes an int for a multiple. It'll say out int number. And all we're going to do is we're going to take the number that you give me and multiply it by the multiple. Oh, goodness. Unassigned out parameter number. Didn't I just do that? Int out int number. Why is this yelling at me? I'm super confused right now. Having a good time. Let's see. We'll jump down to this example then. This is why there's a book, right? Goodness gracious. Out. Out. Is that what I wrote? Set the number. I haven't used it yet. I'm sorry. So int for number. I don't know. What's a good number? 5. I heard 5 first. And then we'll call change number given 25 is the multiple and number. Is that happier? Why is it still not happy? Ah, yes. So I have to match the out keyword. So when you call your function, you call your method, you have to know that it's coming back out, right? That this will be essentially passing by reference. It still hates me. Why does it hate me? Out number. Show potential fixes. Why is that a better? No, that doesn't change anything. All right, well, there goes that example. That's not doing it right. Output parameters. You can also use ref. Ref is a little bit different because you need to make sure it's declared first. But should just work. Okay. Oh, spend a day, outnumber. Number equals, okay, times number. No? I guess I can't use it. Sure, why not? All right, we'll change. We'll give it a value. Let's I can do this. Okay. And then if you want, you can also return things, right? We can have some other value being returned, but we can make it void if you want. It doesn't have to be void. So mostly it's just nice so you can pass things by reference. Integers are pretty silly, not a great example for this, but if you want to pass a reference to something, get it changed, it will stay changed. The one common use case for this here, and it's actually in the library here. So if you go ask someone for some input, or if we're dealing with input here, we can finally do some validation, because we'll get to exceptions. Let's put a text box in here. This one will work, I'm pretty sure. Goodness. No, I want the comment. There we go. Text box, and we'll say convert number. This will be my number text box. Number text box. All right, and when I click convert, whatever they've typed in there, we don't know if it's actually numeric or not. Right? So doing the conversion stuff when we did convert.to whatever, this might crash. Right? So if I try and turn it into not button, sorry, my number text box .text, this is risky because it could crash. Right? I don't know, int some number equals that, and then we'll we got a number. Maybe we want to label somewhere. We'll throw it in a label. Label. Here's my number label. So when we convert our number, we'll take our number label. What was I even going to convert this to? Maybe we'll just double it. Times 2, and set our number label. Label text. Look at that. I love when it suggests stuff. Some number to string. Sure. So this should work if we're giving it actual numeric values. Sure. 10 gives me 20. But if I type in 10, crashes on me. That's no good. So one of the common uses here for out, this is where we're getting here for this, is instead of using the convert method here, you have integer dot, or is it int dot try parse. So try parse is a really cool thing because it will try and parse your number and it can out a result. So you give it a string as an argument here, and then it maybe sets the result here. Right? So, and it gives you a Boolean value as a return of whether or not it was successfully converted. So instead of some number is equal to int try parse, we'll say, hey, some number here, and then we int try parse on that text box, number text box, text, and we're going to out some number here. And then all of this we can throw in an if. If that was successful, we'll go do something here. Else, take my text. Look at that. Invalid numeric input. Or something, right? So doing two things at once is actually really useful here because I want to know whether or not it's successfully converted. And then if it's successfully converted, give me the value, right? So this is pretty nice here that we can get both of those things back out, kind of all in one option here. So let's give this right.
Okay, if I give something real quick?
Sure.
So I'm with student government, and you were nominated for Faculty and Staff Appreciation Week.
Okay. Well, thank you.
No problem. You have a chance to win. It's on the 15th, next Wednesday.
Very cool.
And I have Caitlin here. She was her student.
Oh, hi. Oh, thank you.
About to say hi, yes.
Okay, yeah, definitely. Thanks for coming on by.
Sure. I would stay, but I have my fish drowning and stuff. Yeah.
Oh, so
Oh, question. We have a quiz today. Are you posting it?
I should. I'll try and post one.
Okay, then I'll.
If I
catch you
remember.
on Twitch.
Yep.
Yeah.
Good to see you. Look
Look
at that.
Make sure to take
I feel so special. Thank you. Did you guys know you had a student government?
No,
Okay. So it's afraid of that.
now this moment will live forever on the
Yes, it will. Maybe someone will even clip it, right? That's a thing.
add it to your Wikipedia page.
I tried to make one for myself, and they're like, "You're not notable." I'm like, oh. I just wanted to have one because why not, right? So triparse is so using int triparse will give you ints. There's like double.triparse. We can all the primitive types have triparses that you can use. Fluffy. Cool. So let's give it a try, right? Make sure it doesn't crash on us. So 10 invalid numeric input. 10 doubles to 20. I mean, converts terrible here. We're not converting anything, but I picked the wrong name for my button. So this is a fun case of using out here. Writing your own is a little silly sometimes, and sure, but you'll see this a lot, and triparse is the preferred way of doing this. The other option we have here, and we actually didn't get to that chapter yet, that's exceptions. We're going to do in just a second. We can jump into that, because why not? If you don't want to use triparse, right, the other way we can do this. So let's change this button's name. Here is double with triparse, and I'll add another button for fun, because why not? We can make our own buttons here. Let's try double with exception handling. So we'll make this a little bigger here so you can see it. So when we click this button, we're going to go back and try convert. So we had that before, convert.toInt32. Our text box, our number label, number text box, text. Now, exception handling, I think you all did that in 200, CIS 200, right? With try catch, works the same way, right? So we were going to try something that might throw an exception, and then we're going to catch it if we do get an exception. Again, the base class exception is all exceptions. Generally, people frown on catching exception because you know the specific type. So if you come over to 2int32, down at the bottom here, it's real small on the screen. It says the exceptions you could get here are format exception or overflow exception. So too big for an integer, we probably get an overflow, right? Probably what that means, right? If I go more than 2 some odd billion, probably no overflow, but normally it's probably going to be my format exception. So I'll try format exception here and say, hey, let's catch the format exception. So the throw is when you're throwing your own exceptions. We'll get to that, Fluffy. But this is just handling exceptions first. We can get to throwing our own in a little bit. And then if there's an exception then, right, we'll say invalid numeric input. Otherwise, right, try just keeps on going here. We can do our arithmetic here and say int some number equals that, right, and then multiply by 2, set it to string as my label text. So both work. Now, the nice thing about triparse is that exceptions are actually slower behind the scenes. Because it uses exception handling, the amount of time it takes is more. Now, for one operation here, we don't really care. But if we're going to do something that happens a lot, avoiding exceptions is better because that should be the exceptional case. We shouldn't rely on exceptions for something that, hey, maybe half the time this won't work and I need to catch an exception. That's not a good approach. It's not good design because the whole exception handling process has to interrupt the normal workflow to catch the exception, stop what it's doing, so it messes with what's happening behind the scenes. So this is preferred to use this, but it essentially does the same thing for us, right? And it should work out for us. Yeah, that's something star parse and try to convert. I don't think there's a string parse, so it's just like toString if I convert to a string. So we say 10 and we try with our exception handling. Still works, nothing crashes because we've caught the exception, right? We've swallowed it. That's fine. Same thing with the try, or if we actually have our number, right, it should actually work here. So let's try a real big number here, right? It should actually crash now. Yep. So here's our exception, right? Because we didn't actually handle it right. Our overflow exception wasn't handled. Ooh, okay. Well, we can add handling for that too. So I want to also catch a overflow exception. Now, the little warning here is you technically don't need to name the exception if you're not going to use it. You can use the exception because it has a message if you're going to report that message somewhere. In our case, we're ignoring it, so that's really optional. You can just say catch this exception. I don't care about the exception message or anything, any details about it here. Usually we do something with it, or you might log it somewhere or do something interesting if there's an exception. But if you're just following the message and giving them your own custom thing, then it doesn't really matter which way you're going to go about it here. Let's try something really big again. So try parse just fails, right? We get it back as a false result here by exception handling. Now we're catching the exception properly. So got some options, and now it worked, right? Either way was okay. So out's fun. You can do fun things with it.
Wait, that's not
Yeah.
understanding.
So
Is it like return?
so when you give a value as an out value, you're actually passing that reference here. So I'm passing a reference to the some number variable so that I can set the value inside where this is being run. So try parse will attempt to set the value of some number here. So when I've declared it here, I haven't initialized anything. I've just declared it. So it might get initialized if try parse is successful because it's going to set the value. If we get to if it fails, it's still going to be null because we haven't actually declared it or we haven't assigned a value to it yet. Or like in ours, you say, hey, I want to out, and when we're writing our own methods here, you say, give me a reference to a number so I can go set the value. So we have to give it an out attribute, an out variable to tell C#, hey, I know I'm passing this by reference. Yeah.
The word parse, what is that?
Convert, turn into, read it. Yeah. Does that make more sense what out's doing? Right, we're just giving it the reference to here. So in C# or C++ land, you would have said, hey, I want this as a reference, and then you could go set the values of it. Same idea. So you're just giving this to me as a reference so I can set the value of it so that when the method's done, the value stays set. If we just pass it as a value and you change it inside the method without out, right, it only exists and only was changed inside your method, and then the value hasn't changed. Because when we pass argument, like when I pass 25, I'm not passing the reference to 25, I'm passing by value. I'm saying here's the value 25, you're getting a copy of it here. Without, you're getting the reference, not a copy. Passes as reference. It'll change the number variable here where I declared it because I've passed it to that function, to that method. Yep. All right. Other cool things. Have you seen? Did you ever do default variables or default arguments? I think you can do those in C++, right? I don't know why I'm not remembering. Where did it go? So if you want a default value, you can say, hey, if you don't give me the parameter, here's the value for it. Does that ring any bells? Some people? Well, you can use it for any method here. So we might have like void magic number. Int number is 42. So you can call magic number. If you give me an argument, I'll take it as number. If you don't give me an argument, I'll assume it's 42. Here, and then you can do something with it. I don't know, set some label somewhere. A number label, number label. Oh my goodness, why am I not number? It is number label. Come on, type ahead. Text is number to string. So in here, I can call my magic number function with no arguments, or I can pass it a value. Right? Both are valid. So it's similar to overloading, but it saves you some extra time. So the way to do this without default parameters is you would overload the method and have more than one. I could have public void magic number this way, and if that was the case, then I would call magic number given 42. Right? You might have seen something like this, where you have one version that takes an argument, one version that doesn't take an argument, and it just gives it a value. Does this ring any bells? I don't know what you guys did in 200 or who you had in 200. I'm so confused now.
I had you in 200.
I know, I don't remember what we did.
Even better.
Yeah, it is. It makes me feel good. I'm having a bad winter. So overloading here is fine, but it's a bunch more typing. So having a default here is just a shortcut for that. Right. So let me just comment that out. So instead of overloading, add default values to parameters. Does that explain it? I feel like we did.
Yeah.
Okay, good. So it's your fault for not remembering it, not mine.
Yeah, that's on me.
Yeah.
We have multiple parameters.
Yep.
Do we default from the bytes though?
Yep. So you can have multiples. So we can have int another number, 24. Let's go 77. 777. That's a good one. Now, when there's multiple default parameters, things get really confusing. Real easy, right? So I pass one number, magic number, pass number, and 27. I don't know. Sure. I've got one, I don't have the other. So one of the cool things you can do is you can use named parameters or named arguments here. So for magic number, I can say, actually, I never remember how to do this here. Named arguments. The name of it, colon, the value. Now this is going to look silly here, but the two parameters here are named number and another number. So I can say, hey, I want another number, colon, to be 27. Comma, and then I want number, colon, to be 15. This is using named arguments. There, okay, yes, that red line went away. So this is nice because you can see which one is which here. And when you name them, they don't have to go in order. So usually our arguments are positional, right? The first thing is the first thing, the second thing is the second thing. When you name them, C# says, oh, sure, put them in any order you want because you named them, which is nice. And then also, if there's more than one default, I can just specify one argument. And that's the important use of being able to name these things is I can say, hey, I'm going to give you another number, but not number. Because there's no way to do this without named arguments. Because you can't give the second thing positionally without giving a first thing. Right? If you have more than one default argument, you can't get to the last one on the list without giving all the other ones if you're relying on position. So being able to name them is important so that we can skip ahead if we want. So you can do all sorts of silly default arguments for things. I think usually there's an example of like date, and it defaults in a particular format, it defaults in a year, defaults in a month, defaults in a day, and you can give it any range of those if you want, because why not, right? So we could say void set date, given a int for the day, an int for the month, an int for the year, and string for format or something. I'm trying to remember how you'd usually do that. Format. We could come up with something better actually, but that's okay. So the usual format here, right? US format is month/day/year. No one else in the world does that stupid format because it doesn't make any sense. Why do you start with the middle size, then go to the small size, and then go to the big size? It's just dumb, right? Everyone else in the world does day, month, year, small, bigger, bigger, right? Computers go the opposite. They do year, month, day because that's the ISO format, and then it actually sorts really nicely for you when you alpha sort. Sorry.
Especially, I think it just has to do with like how you talked about it, like syntactically. Like I don't know anybody that says like, oh, what's today's date? It's the 22nd of February. I always hear it's February 22nd.
Sure, but speaking is different than writing. Sometimes. I don't know. Yeah.
I wonder how people in Europe talk. Like, do they say it's the 22nd of February instead of February 22nd?
Maybe. anyone actually European?
If you go to France, I'm just looking really disgusting or something. I should know. I went. It was the entire time I was living in the. You can also impact. I think French. That's French by the right.
Was it in Paris?
Yeah.
So for some reason, people in Paris hate tourists, despite it being like one of the most popular tourist destinations in the world. It seems like native people in Paris just hate tourists. Probably, yeah, because it's popular. Like, get out of my city.
France, when I watched it was so good. Speaking French, I haven't really done that much anymore. Because I was back in high school. It was like a trip we took, and I asked the waiter, because I don't speaking in French would be more better. Just or sorry, it should be better. They'd be a lot nicer about it instead of speaking like that. But in English, they'd be like, fine. So I said it in French. Can I have a croissant and some coffee, please? Thank you. And the waiter, who's a lady, who's looking like walk away. I'm just like,
Because you had a terrible accent, I'm sure.
like I'll be nice until I'm like, okay, I'll just not be nice.
Yeah, it's I don't know. There's all sorts of weird things. People are weird. I understand computers. I understand numbers because they make sense to me, right? And they're predictable. You give it something, you get the same output every time. With people, it doesn't work like that, right? I can bring flowers home to my wife every day. Most of the time, she's happy about it. And one time, I bring her flowers and she gets pissed at me. I don't know why. Like, it doesn't make any sense. It's not the same input and output. I don't get it.
Parents like that because I went to like I went to like jail because I went to Albania because I went back to my grandparents there. For both times, those countries be like that. They're also pretty nice. Like the Italian special on top, they have a bunch of workers there. They're all like super nice. They give you tips and advice.
Nice.
Like, but then again, compared to France, they're all like.
Yeah, I don't know. Different cities are weird. So, all right. So if we wanted to have different defaults here, right? So we can say, hey, this one's 2023, month would be 2, day would be 9. Sure. And we can say, hey, if my format, or did I say format? Yeah, format. I don't know why my type ahead's not working. Equals US. Then we'll set that. I don't know. Let's do another label here. Why not? We like labels. Label. This is our date label. Date label. Take our date label. No, goodness. Date label. Text. Now we need a nice little formatted string, right? So if the US format, we want month first, slash day, slash year. Sure. If it's not, right, how about else if the format is, I don't know what, EU? Can we just say EU? Is that okay? It's probably fine. Then we'll do it differently. We'll say, hey, I want day slash month slash year. Sure. And then else we'll just, we'll not even have another option here. This will just be the ISO format. And you'll get year dash month dash day, which is the superior format here. And it sorts for you. Like if you do stuff year, month, day, it'll just alpha sort. And it's right. Because sorting alpha sort with day, you get all the days matched, which is not a useful sort here. So this is, computers usually use the ISO format, and life is better. But anyway, sure, so we can set the date. So let's add another, let's do a drop down. We haven't done one of those yet, right? Do we do, where is it here? It's not a list box. Goodness. All my controls? Check, no, I don't want checks. I think it's Combobox. Is that the one we want? So the Combobox, I need to edit my items. We'll have US, EU, and ISO here. So we should be able to pick one of those items in our Combobox here. And then we can get a format. Let's see. So that's our format here. Let's get we can do that on pick here. I think this one has, what event is this? Selected index change. That sounds right. I don't even remember how to get those values out. Goodness. Combobox. Items. Selected index. Gets or sets the index specifying the currently selected item. Let's go ask the chatbot because this is super entertaining. Log in. Come on. Right. You get the selected text from a combo box in C# forms. Maybe that's it. Text property. That's it? I feel like that's different.
You need to be more specific.
I don't know. Let's find out. Oh, selected item. Oh, okay, because we don't want the object. Selected text. Selected text. Okay, sure. All right, so here's our string for format then. So we can call my set date here, and we'll give it as the format here. So we'll say format is the selected text. Let's give that a try. See if this works for us. All right. So do you want EU, US, or ISO? US format. Uh-oh. I think it's giving me the else every time here. Right? Well, that's okay. Here, let's
Finding a better format for you.
that's true. I think I need a string format first. Format is selected text. This is why I think that was wrong. Format. That makes a lot of sense there, right? That looks good. Restart that. All right, try it again. EU. Oh, I lost my breakpoint. There it goes. US, EU. Okay. So the selected text is nothing. That was not helpful. What does my combo box have? Combo box. Way too many properties here. Does it have text? Ah, I guess it's just text. I should have taken the first suggestion from the chatbot. Chatbot is smarter than me. Okay, chatbot 1, Eric 0. I accept. It's okay. Let's take out the breakpoint. All right, we got US format 2/9/2023, EU 9/2/2023, ISO. It's working so far. Now, if we want this formatted better, though, right? This formatted string, you can give formatters. Did we look at that yet? So you can format a string. Format string with specific number of digits in C# with string interpolation. Look at that. This is so much better than Google. Now, I don't get free coffee like Bing gives me, though. I'm sad about that. But apparently, they were trialing Bing with ChatGPT enabled, or like ChatGPT support, and their whole like internal team was super excited about it. I read it on Twitter.
Weird. Cool.
I'm sorry?
I didn't miss what you said about Google. Like,
So
what are you doing, or like,
Bing is working on a version of Bing that will integrate ChatGPT features because Microsoft was an early investor in OpenAI who created the ChatGPT bot that we're using. So they're like, everyone's super excited about it internally. It sounded really fun. And they're like, hey, Bing's been around for 15 years and we're finally like in the news.
Google is already checking.
Are they? Okay.
yeah, that's everyone's like,
Yep. I mean, it's pretty exciting. I don't know. I'm excited by this sort of stuff. I think it's neat.
I'm sure they're doing a great back on Twitter. Someone uses AI to like make an R-rated scene movie scene into a PG-13 one, turning the metaphor into freaking, and it's almost uncanny how well it works.
Nice. All right. So :D2 looks like for digit and then the number of digits, right? 4 digits. Sure. Let's give that a try. US. Okay. 020923. EU 090223. ISO 2023 0209. Looking good so far. Awesome. That was exciting. So defaults here, right? If we want to have other dates, we can have other dates, right? But this way we can say, hey, I just want to give you the 4th item in your positional list. Here's the format. Keep the date defaulted. We could go add other text boxes and other drop downs and, have some sort of date picker here. Now, sound like the biggest nerd. I am. It's okay. I accept. On Twitter, there was a thread around the worst possible date picker you could come up with. And it was like sort of a competition style. Like, who can come up with the most terrible date picker? Think we can come up with a terrible date picker? One of them that was got a lot of good I don't know, votes. I think they got a lot of votes. Was using sliders. Where's my slider?
What about like a binary search type thing where you have like a small sphere and a biggest sphere and you tell it whether you want a bigger ear or smaller ear.
Split the difference.
Yeah.
Where's my slider? Why is it not? Why is it not called slider? I don't think it's a scroll bar because you scroll the track bar. Why would you call this a track bar? Sure. All right, let's call this one the year track bar. So with the year track bar, we need to give it some values here. Let's see. So our kick frequency, every 1, sure, why not? Here's my min and max. Let's size maximum here. So maximum, say, I don't know, 3,000? Minimum 0? That sound good for a year slider? Here's a year. Okay. Now when we go pick our date here, we'll go get the date here. So our int for the year is going to be my year slider, year track bar dot value. And we can pass the year as the year. Now this is only going to update though when this one changes, which is kind of a bummer. What we really want is when the slider changes for it to do something too, right? So on scroll, let's do that too. Let's set the date as this one. And now I have the same code twice. I should feel bad about myself, right? Yes, you guys are catching on. You're good at this. So let's refactor here. So quick actions and refactoring. I want to extract method. Call this update date. And we're going to update the date. Now it wasn't smart enough to pick up this one though. That's a bummer. But we can copy paste. So now I have a function or method, sorry, that does this. They're called, I don't know. I wish everyone called them methods. I bet I used to calling them functions because C++ and Python call them that. But that's fine. Let's rename that one. Sorry, it should be naming violation. Should be an uppercase letter. Update date. That was a F2 or right-click rename. Let's give that a try. So let's go to ISO format 0. All right. Okay. Here's 20, 20, 32, 23. Oh, I found it. All right. That wasn't too bad. Okay. Should we add other sliders for month and day? No, that we're okay. We had enough fun. All right. Cool. It's about 7 o'clock. Should we take a break?
Yeah.
All right. Break time. I like it. We'll see you in about 10 minutes or so. Okay, thank you. Oh, hey, can we come up Visual Studio Community because that's the free one. We don't have to bother. $707. All right. Wolf, my posture's terrible. Thanks for checking. we'll bring it on back here. Oh, I faded that out too fast. That's okay. All right, so arguments. Oh, we didn't even finish our different arguments here too. That's okay. Another fun thing you can do, if you want a variable number of arguments, you can use this params, and it essentially gives you an array of values, which is kind of cool. Real special to use case, but you might see it some places. So you can pass it any number of that type, and it just gets turned into an array behind the scenes, which is fun. So if we had, say, what do we want here? Void, there's was, we can say sum, and I want params for int numbers here. I can get the sum. Oh, we got to return here. Let's return a type int here. I can now say, for int number in numbers. We got to start equals 0, sum plus the number. Nothing exciting. Add it and return the sum. Nope, return sum there. Is that going to work? Nope. Total. We'll call it total. Total. Yeah, yep. Thank you. In for each. I can't remember how to do loops. There we go. For each in numbers, add it to total, return the total. So if you want to give a different number of those, right, I can call sum given one value, or sum given a couple values, or sum given, I don't know, a whole bunch of numbers. Doesn't really care. Any number of integers then just get jammed into this as an array. Just a convenience so that you don't have to tell the person calling your function you have to give it an array. I could just make an array and pass the array, but this is just syntactical sugar, make it a little easier for people to use your methods. Again, pretty specialty. Like if you want some number, I think a nice funny example of this, like if you're doing a little menu program and you want, what toppings do you want on your sandwich? It can be an array of strings for all the toppings. And if you want pickles and mustard and mayo and ketchup and relish and all these things, sure, you just give them a bunch of things, just strung after another. If you just want, like my daughter, cheeseburger plain with nothing on it, then you just don't pass anything. Sure. McDonald's hates us, by the way. Anytime we go through the drive-thru, they hate us because my one daughter's vegetarian, my other daughter eats plain burgers, my son doesn't like mayo on things. I don't know. I eat a lot of things, but my kids are picky for some reason. So I don't know. I feel bad every time I order at McDonald's. The mobile ordering is nice though, because then they don't have to do any of that.
Or like the kiosk ordering, you go inside, and you just type in one.
Yep. It's not bad. Not too bad. All right. Yeah, more arguments there, parameters, yeah, combinations, passive reference. Cool. We did that one. Extension methods are really neat. These are pretty fun. So this is going to look real weird here. So you can make a class that gives you extension methods to make it look like there are methods of another class. That probably doesn't make a lot of sense. But when you have a string, let's say, here's my string name is Eric. And I say name dot. I get all these string methods here, things that I can do with strings, right? Bunch of methods. Not everything. I think a lot of things you can do with strings. So if you want to add some functionality and add something, hey, I always want to do this to strings, like maybe I always want to just go scramble them because I want to add some sort of silly scramble thing. We can make a class that is a static class for extensions here, and you add a static method. I'm going to steal this, but then change it around a little bit here. Let's come down here. Jam another class in here. This is scramble. Scramble. And it uses the this keyword, which is really weird. So we're saying this string, which would be our text. So you have to give it some text here. We're going to do something with it and give you back a string. So that this keyword is important when we're doing string extensions. So we don't need the capital thing. We want letters. We don't even want letters here. We want to take all the letters, let's throw them into an array here. So we'll take an array, so we want a character array, characters. This is my text.toChar array. It's like a built-in function for that, which is cool. Now I have an array of characters. Now I want to scramble this characters array. Is there a, I thought there was like a randomize. How do we, let's go back to the chat bot. How do you randomize the element in an array in C#? Let's see if the bot can tell us. I think there's a quick one. There we go. Yeah, the random class. There we go. Random equals a new random dot. What is it here? Oh, really? It's not like a built-in one? It's gross. I want a built-in one. Is there a library? Built-in library? Built-in library method? Oh, lame. Fisher-Yates shuffle algorithm? Sure. All right, we'll just do it that way then. We'll go scramble it up this way. So this is with my characters, right? Length. Take my characters from chat GPT. My prompt was, what did I ask it to do here? Right, we're gonna be good inside our source, right? This is what good people do. I would like that, yes. If you didn't, that's okay. But like, just telling me it came from the website doesn't really help. Like, if you use this, you can sort of recreate it, which is much better. That's all. Okay, cool. And then we can return. Now I don't want results. I want my characters to string. I think that'll work here. Static class, static method that takes a this of a type. All of that now to say, I can take my string here, name, and when I say dot, I now have scramble. It looks like magic. Kind of is magic. So it looks like we've added a string method to the string class, but we did it on our own. Right? Because this class is included here and it knows about this class, it says, hey, if you have a string and you use dot, the notation on it, right? It looks up and says, oh, there's a method called scramble. It'll give you back a string. So I can say, I don't know, let's just take that label somewhere. Label, here's my label. That's why. Label, what do we want here? The date label? Sure. Text is name.scramble. And I'll add my whole name here because otherwise it's kind of short. It'll scramble a little bit nicer this way. So this is in when it just starts. Sure. So our date label should get scrambled. Oh, system char. Oops, that's not right. I need to give it, how do I get that as a string? You can just say string. New string. There we go. So string has a constructor that takes an array of characters, because why not, right? Let's try that. There we go. Nikisasa kihi iri. I like it. And scrambled. Sure. Super secure, right? No one will ever guess. So extension methods are ways to add methods to other classes that look like they belong. Just some nice shortcuts. So if you're always doing something into strings, it just is a easier format here. Oh, I don't need that result, right? All right, get rid of that. So we could do the exact same thing with our own method that's not a string extension, right? We can just write a public string scramble that takes a string of a text, does the exact same thing here. Scramble, there we go. And then we could do it that way. We could say, hey, I want to set the text to, now with the scramble method given name. Now we call the method, give it the argument. This way you get the dot notation, so it looks like it's a built-in method. Does the exact same thing, right? This is just, it looks fancy, essentially. And maybe a little more discoverable, I think, is the main benefit here, right? So if you build out this library of extensions for things you do all the time, and you don't remember all of them, right? I can just say name dot and see all the different things I know how to do with string now, because it looks like it's an available method for string. So it's just a little shortcut here. It kind of reduces some of that memory load. You don't have to remember that you have a method named Scramble. You just say name dot, and you get to find all these things here. So that's the big benefit. And then you can add some other fun stuff there. So it should give me the exact same result, though, right? Whichever one I'm doing. Yep. Ikashi Kurani. Yeah, sure. All right, so that was string extensions. Methods, awesome. Okay, finish on methods. We did the exception and error handling. For throwing exceptions, this is the important part, and this I feel like never gets covered well enough in 200. Yeah, I'm sorry.
Yeah.
You just shout at me here because I'm just gonna.
For the scramble class, is the class name has to be an extension?
No, this could be ABC. Naming it string extensions just lets you know that this is what it's designed for here. We'll just make you just a convention here. Should work the same. Yeah, it doesn't care. Ooh, IE crack. Snahari. Yeah.
In the handle, like the extension, like actually change what's in the name.
So remember, strings are immutable. You can't change a string. You can give back a new string though, right? Because that's just one of the reasons strings aren't changeable; they're immutable. If you write an extension for a class that is mutable, yeah, you're welcome to go change it. But like in this case, that's just how strings work. Yeah, that's a good question. So throwing exceptions. This is super important. So when you write a class that does something, right? One of the rules or one of the design ideas with object-oriented programming is that we've encapsulated all of our details. We let people work with us in an abstract manner. They get our public methods. They don't need to know any of the details here, right? That's the principles of object-oriented programming. Now, if you try and do a bad thing with that class, the class needs to protect its integrity, right? If your class depends on certain values being within certain ranges, you have to make sure those values are within certain ranges. You can't let yourself be invalid. So the way to communicate that is not by console write line, right? Because no one is going to guarantee that they're going to use your class at the console or do anything about it here, right? You want your classes to be usable, to be used in user interfaces, graphical user interfaces. You want it to be used in web applications, all sorts of different things. So the exception is what you use for that. So if you throw an exception, it forces whoever did the bad thing to fix it or crash. Right? And that's how our classes communicate. So if we write another class in here, I think rectangle is like a nice silly little example. So if a class for rectangle, and it has an int for length and an int for width, right? And these should be private, right? Private int. Actually, no, we can do these as properties, right? So public int width get private set. And look at that, it's even suggesting height. I love it. Probably, I think we use capital letters here for these, right? And then we write a constructor. So public rectangle. The constructor then will take an int for length and an int for width. But before I set those values, I'm going to sanity check them, make sure they're valid values. So a rectangle can't have a negative length or width. It just breaks the laws of, is that physics? Reality? I don't know, whatever you call it. You just can't have a negative length or width, right? It's just not there. So I'm going to check for that. I'm going to say, hey, if width is less than or equal to 0, this was invalid. So I throw a new argument exception, right? And we can say invalid or some sort of method must be greater than 0. Sure, why not? I can do the same. Why stop calling me? With the height. Right, so if the height is less than or equal to 0, throw an argument exception in. Otherwise, then we can just set width is width. Yep, width. And height is height. Look at that suggestion. I love it. So if you throw, remember your code stops running immediately. So we're never going to get here because the code stops. The method stops going. It's a hard stop. Right? Whoever tried to give me a bad width or height now has to go catch the exception and do something about it, or their program crashes. But this is my class protecting its integrity, making sure it can never be in an invalid state. It's very important here because everything else the rectangle is going to do, if it's going to tell you the area or the perimeter, or it's all really rectangles do, depends on these being actual valid values, right? If they're negative, I'm going to give you garbage. So the class uses exceptions to communicate to the calling class. And that's the important piece here with throwing exceptions. The finally block for cleaning things up, that's all fine. I think you've done that before. So it will only catch if the exception is not thrown. No, so it only gets to this part here if these aren't true. Right? If either of these is true, we throw the exception, and the constructor stops running. There is no rectangle that gets created. It just stops. All right. Delegates. These are a little crazy. A delegate is a variable for a method, not a value. It's a little weird, but what it lets you do is say, hey, I want some sort of method that looks like X, Y, or Z. And you can give it any method that fits that X, Y, or Z, and then we'll go use it. So a couple silly examples he has. You can add one, you can subtract one, or you can double. They all take a number and give you something. So we're going to steal his examples because this is nice and easy. So we'll add these in here. Let's see, maybe up in here. This is player's guide. It's just our fancy expression here, right? These are expression-backed methods. Right? It's just instead of putting it in parentheses or in curly braces and saying return. Right? I think we looked at these. Right? Okay, cool. Takes a number, does something with the number. That's it. That's all they do. So what you can do then is you can define a method as a delegate and say, hey, I have a specific return type, I have a specific argument type. So the argument type here and the return type here. If you give it a method that matches, like add one, it accepts a number as an integer, it accepts an integer, returns an integer. You can give add one in place of or as a number delegate. So if you want, you can do some silly things like, hey, give me some code here. I'm going to write a method called change array elements. You give me an array of numbers and you give me a number delegate. I'm going to go use the number delegate function method here. I'm just calling it operation. I don't know what you call it. You just give me something. I'm just going to call it the operation here. And now I can loop through. So I need a int result, new int here, and then for each int number in numbers. Oh, I want to do a loop here. Sorry. So for index is 0, index is less than numbers.length, numbers, index plus plus. Let's take my result at index and assign it the value of my operation of what number? Operation of my numbers at index. So operation is actually a function. So I can use it like a function because number delegate that we've said, hey, anything that accepts an integer and gives me back an integer can be given as a number delegate. It matches. It's like it fits, right? So I can call it then, and it will do the method that we give it. When we're done, we're going to return result. So if we wanted to, we don't have any of those right now, but we could. So I can call my change array elements here. I can say, hey, change array elements. I need an integer array. An int array of numbers equals a new int array. Actually, we can just give it some values here, right? Like 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that. 8, 9, 10. Sure. So I give it numbers. Then what I have to give it is a number delegate. I have to give it something that will fit the number delegate form that accepts an integer argument and returns an integer. I can use any of these other ones we stole. I can use add 1, subtract 1, or double. Let's give it double. So I give it the name of the method here. Notice there's no parentheses. I'm not calling the method here. I'm giving it the name of the method because a delegate is a method. So now I can go do something with it. A little weird, right? It's got some really interesting use cases here. A very practical one is for logging. If you want to accept a message and do something with it to log, right? You might have different ways that you want to log things. Maybe you want to log it to a file and you want it to write to a file. Maybe you want to log it. There's this cool thing called the event viewer in Windows that you can log to. You're going to log to the event viewer. Maybe you want to take that log message and send it out to the web somewhere, send a web request somewhere. Sure, we could do that. So you could give it a different method depending on what you want to do. Here, so hey, I want to start this up and I want to log to my file. So I would give it the file logging delegate, or the one that matches the delegate for logging that will log to files. So it lets you kind of substitute things in. It's very similar to interfaces, where I'll have an interface that looks like something, I can treat it like the interface. But now I don't have to go through the work of calling all the methods, right? So the other way of doing it, so if I wanted to go through the work of writing an interface for this, we could do that. If you want to, what if we want to give the method we want to call a value? How do we pass that to the delegate? So when you call operation, when you call the delegate here, you give it the value. Right? This is the argument or the parameter for the delegate. So the slow way of going about it here, right? I can go write another class. So here we'll write a public interface. What do we call this? Our number operation. I number operation, right? Because we like to name things with i's for interfaces. And we'll say I want an int called operation that takes an int for a number. Great, there's the interface. Done. So I will have a method called operation, accepts an integer, gives you back an integer. So I can go write a class like add1, public class add1 that implements iNumber operation here. And all it's going to do is take, we're going to return number plus 1. Again, we could write another class. We could add subtract 1. We could write the double here. I guess we might as well. Why not? We'll call it subtract 1. So subtract 1. I'll skip double. Is that okay? We'll have 2 of them here. And then where do we do this up here? So instead of this being a change array elements that takes a number delegate here, we can write this as a change array elements that takes a I number operation here. And now it'll be my operation. Maybe here's the method's called operation. That's annoying. I want to call this here. I don't know. Number operation. Here we go. That'll be number operation dot operation. It's going to do the exact same thing for us. Now I have to pass it a class to do it. So the delegate is kind of a little bit of a shortcut for us. I don't have to go through the work of defining an interface, defining a class, adding the methods, implementing all of it here. Shorthand for us. Does that make sense? This is the long way. This is the shorthand way for our delegate. Right, so then I could go, if I wanted to use that, we're using it here. So I could say change array elements, change array elements given numbers, and then I want a new add1. Right, because I have to give it an instance of the class here that I can work on. We didn't define it as static. That's probably my bad. I made those static, but that's fine. This is a little weird. I'm sorry. These are the advanced topics. All right, there's change. There's some pre-built-in delegates then that are commonly used. There's action and function. Predicate I've not seen as used as much, but it's out there. So action is a specific delegate that is a void return, but you can use template types. So say, hey, I want an action of type string to do something instead of writing a delegate that takes an argument for string. Just a little shorthand for us. So we've got these pre-built-in ones to use on top of that. So we have a shortcut for our shortcut. Or you can say, hey, I want an action of type string int bool that does something, right? It gives a string, takes an int, and has a Boolean argument here. So we're kind of expanding on this idea. And then functions are different than actions because they return a particular type. So they have whatever list of t arguments you want here and the t result type that you specify. So if your do something method is going to return a double, you'd say, hey, I want a function for string int bool double. The first bunch, everything but the last one, are the arguments. The last one is the result type here. So we could write these as func int instead of number delegate. Right? We could save a little bit of time and say, hey, I just want a func function. One more here. This will be a func of int called operation. Now I don't have to go through the work of defining number delegate. I still could just hand it these things and life is good. We're okay. Just a lot of shortcuts, a lot of fun stuff you can do with these. Then you can start chaining delegates. So he says, hey, later on, he'll show you more where you actually go and use it. This is the interesting stuff for sure. You know, once you get to events, we'll start chaining these things together. But you can add more delegates. So this like idea of, hey, I want to log something here. Now I can add the log to console delegate. I can add the log to database delegate. I can add the log to text file delegate. All the delegates now get to go work, which is awesome. Right? All three of those will run behind the scenes when you call it. This is where it starts to get interesting. You guys look bored. I'm sorry. It's a little rough. It's a little rough. Now events. The next level of this. Events are super cool. So the idea with events is it allows us to use a pattern. This idea of a design pattern. So we're going to have things that watch. Where is it here? Our event handlers. Where did it go? I passed it already. I'm sorry. Goodness. Where did it go here? This listener and observer. So this idea of an observer pattern. So yeah, you just got to look for the bold. This was not bold though; it's italicized. I missed it. My eyes are trained to look for like bold words. You know, you're reading a textbook, you're like, hey, here's a bold word. I have to read it. We all do that, right? Not just me. Okay, good. That's what I thought. So the idea with observing is you're just going to sit and wait and watch for something to happen, right? Or you're listening for this thing to happen. So this is the observer pattern. So you can say, I want to know about events that happen when you do something. So we're going to have something that observes the events of another object. So what's fun is we can change around our Yahtzee game. I don't know if we'll have a chance to get to it tonight, so that when the Yahtzee dice class itself changes, maybe we'll have time for that. I don't need to manually go and update all my labels. I can set my code that has all the UI to observe the class for changes. And when the class changes, it triggers an event and says, hey, I've changed. Anybody who cares, I changed. And if you've subscribed to it, if you've added a delegate, said, hey, I want to pay attention to this, then your method can run and go and update itself. It doesn't have to be based on a button being clicked. It can be based on the class changing. And as we start getting into more following things along and dealing with games, right, you don't want to have to wait till someone clicks a button. If a unit changes its health, you want that to show on the screen. Right? So we got lots of different ways we can respond to events happening and have different things all happening and listening, observing for these changes, which is really fun. So we're going to use the event keyword to say this is an event then, and then you give it the delegate type. To say, hey, I've got an event, something's going to happen here, someone needs to go listen for this. or can listen for this. What happens here? Then you can say, hey, if something happened here, right, this is the ship exploded event, you can either, the newer style is call it like a method, or invoke is a little bit more common. I think this is probably a little more older school, but you'll see invoke more often here. And say, hey, if anyone's listening, go invoke all their delegates. So then when we're dealing with this, right, we want to say, hey, when this event happens, run this method, please. Here's my delegate that matches. This delegate cares about this event happening. So on ship exploded, right, we'll run, and it will play some sound effect. And this is just his example code in here. So we can set this up to say, hey, when the value of my dice change in Yahtzee, in my Yahtzee dice class, invoke an event. Anybody who's listening then can go and handle it. So when I build my UI, I'll add to the event an event handler. I'll subscribe to their events. I'll say, hey, I want to observe. I want to see what's happening here. When you change, let's go do it. Should we try and modify Yahtzee? Does that sound like fun? I think that's probably a little easier to follow example than his ship stuff. But again, he shows you the slow way, right? We could build out an interface, do all these handlers things, or we can use our shortcut with events. You can do similar things. Sound like fun? Let's try it. So let me open up the Yahtzee project. So let me commit this here. So here's part 2, week 6, part 2 nonsense. And then we'll go open up our Yahtzee project. Here's my open. Don't I have a recent? Where's my recent? All right, that's fine. Yahtzee. Okay. So in our Yahtzee, we're going to go to the Yahtzee dice here. So the Yahtzee dice. So we need to create an event that someone can subscribe to, right? This idea that, our class has an event. When something changes, we'll call this and say, hey, something happened. Right now, these are actions. So the delegate type here is an action. Remember those built-in delegates? You can specify other delegates if you want, but action is just, here's a method. Right? There's no return type. It's just some sort of action. Okay? So we can take an event of action, and this will be, I don't know, dice, or how about roll, maybe. We'll call this a rolled event. So when the dice are rolled, we'll tell everyone that our dice value changed. So in our roll method, right, when we're done here, you can say roll, capital R, rolled. Now, more common, you'll see this rolled question mark dot. Remember, this is if it's null, stop. If it's not null, keep on going. Because it's possible that you have an event that no one cares about. No one's subscribed to, no one's listening, no one's observing. So if you try and invoke and then no one's listening, it's going to crash because you have a null reference exception. That's ugly. So this is more common, I think, than you'll see the syntax. Oh, is it suggesting I change it? Why? Introduce parameter. I don't want a parameter. Why? Okay. I thought it was giving me a suggestion here. That's not helpful. So we can say, okay, great. Invoke, if anyone's listening. So back in my UI here then, and my roll button. Now, it's a little silly. This example is a little contrived because you click the roll button. That's the only time you would roll the dice. So we had it working that we're going to go change the values here. Right? Once we roll, we're going to update labels, but we're going to show you that you don't need to. It's just a different model here. Is sort of what we're getting at. And then this is nice if multiple things could possibly interact. It's not just for dice here. Like you can use it for any class that can change values. We can add this observer pattern and you can follow it and it will change, which is nice. So once we roll, right, we're going to have that event's going to be fired. So somewhere in here, we need to have, what do we want to do when that happens? Right, what method do we want to have run? I think we had one in here. Wasn't there Let me check. Isn't it update dice or something? Update dice labels. There we go. So the update dice labels could be our delegate that looks like an action. Right? It just does something. So we want this to be the method that runs when that event is fired. Right? So in our init method here, let's see. So in our dice, so dice here, then I'll say dice dot rolled plus equals my update dice labels. Again, method name, no parentheses, right? Because I'm saying, hey, here's the method. I don't want to run the method. If you add parentheses, it runs the method. I'm just saying here's the method name. So when the dice are rolled, go do this thing, please. Now I think we got to double check here. Every time we set up a new instance of dice, what's going to happen to this? Is this going to be? Do you think this will be listening to a new instance of dice? Right, because it's attached to this instance of dice, which is the one we created here. So we need to make sure every time we're creating dice here. Let's see, where else do we have dice? Dice. I thought we made new dice somewhere. Yeah, here. So once we make new dice, again, we want to resubscribe here. Say, hey, here's a new instance of dice. Because you can have 5 different instances of classes, this method could be subscribed only to the first instance. Maybe you don't care about instance 3, 4, and 5. You don't want that event to run, or you don't want your delegate to run every time for 3, 4, and 5. You only want it to run for number 1. That's an option, right? So when we're using instances of things, I think this makes sense. You want it to run for this particular instance. So every time we make a new instance here, we'll go do that. There's it. I want new, there we go, new dice. So new dice, and we update, new dice, we update. Okay, that's, yeah, fine, but it's good there. Okay, so that should run the update dice label. So now I'm going to go find, where do we update dice labels? I think that was in update labels, right? Update labels. So if we don't call update dice labels here, when we update labels, we should still get the dice being updated, right? Because we've subscribed to that event. When it changes, this update dice label should run. So we can look and see, let's go, where is that one here? Sorry, F12 jumps to a method. So if you're on a method and you hit F12, it'll jump right to it. So let me go, where was I here? Like if you can right click, you can say go to definition. That's the shortcut here. I try and explain the shortcuts I use because I use them all the time, and sometimes I'm bad at that. So it goes to the definition. So let's put a breakpoint in here to see if this is going to get fired, and we'll take a look at the call stack. See if we can do that. So roll, it gets fired. So we're in dice roll line 72. We're invoking, right? Roll was called. Awesome, and now it's being invoked, and this method's running, right? From invoke, because rolled has something subscribed, right? The method update dice labels has been subscribed, right? It's listening, it's observing, waiting for that. We'll continue. I think there we go. So it was a little wrong though because we didn't have the initial values, right? You notice when I first ran it, it had all the blank labels here. So it's not quite right yet. Right? It listens when it changes, when the roll is called, but when dice gets initially created here, we pick some random values. So it's not perfect yet. Now, the problem is if I try and fire this event off in the constructor, where'd it go? My form code here. When I can create dice, new dice, right? Dice, there we go. This is the constructor line. Before the constructor is called, I can't add a delegate. I can't add a listener for this event, right? Because it doesn't exist. So your constructor is not supposed to fire events because no one's going to listen because the object doesn't exist until the constructor is finished, right? So small problem there, but it's okay. We already have the function that does this. We can just say, hey, after I make the dice, right? Let's go update the labels. It's a little silly here, but it's probably okay. Update dice labels. We'll just call for it to happen to make sure we get the values. Then we'll say, hey, every time you're rolled, go update again. So it feels a little silly. We haven't really gained a whole lot here. Let's see. So new dice. Come on. F3. Find again. Here we go. So every time I make dice, I'm going to update dice labels initially to get those values. Then I'm going to subscribe and say, hey, when you change, tell me you changed. Right now we should get our actual values to start. Oh, I don't need the constructor here, sorry. Or the breakpoint. Continue. Now we get the right values. We have 2 rolls left. Now what, we want to hold our 1s, maybe? We roll, and they changed. Right? Let's hold the 6s, maybe we'll get a full house. And we didn't get a full house. Let's score 1s. Right? New values. So this is what's cool with events. Right? You say, hey, I want to listen. When this thing changes, tell me, and I'll do something about it. So similar to when you have event handlers on our GUI controls. Right? That's actually what's happening behind the scenes. The GUI control, right? If we go and look at the code here, the designer code, we go open the sucker up and look at it. Let's see. If we got too many labels in here, we want some buttons. Buttons, right? It says, hey, when this click event happens, what are we going to do about it? Well, let's subscribe a new delegate here. It's an event handler given this. So this event handler is like behind the scenes, don't worry about it. But it says, event handler, do this method. Right? That's how it's wired up. It's actually, we've been using events this entire time. It's just the tool did it for us. So now we're doing our own. When this value changes, when this event is fired, please do X, Y, and Z. And with delegates, right, you can have more than one. You can add more than one delegate if you want. So if you don't want to just change your dice labels, if you want to do something else, we just subscribe another event handler. Say, hey, also do this method, please. And we make that chain of delegates. Call this one, call this one, call this one, call as many as you want here. You can go nuts adding them, which is pretty fun. We can do some cool things here. Does your head hurt a little? It's okay. Mine does. It's weird. It's a different way of thinking about things. So I think eventually the 400 level you take design patterns as a class. I don't know if that's required or an elective for you. I don't recall. Super interesting. So this listener observer pattern is a very common way of doing software. Say, hey, you tell me when something changed, and I'll do something about it. Which is great, because most of the time we just want to sit around and wait for something to happen, right? Whatever we're doing. So that's events. Events are really cool. Yeah, again, this null event, usually it's nice to do the null checking. So I prefer that. Cleaning up or disposing stuff is tricky. We talk more about that later on here. And then event handlers, sure. Yeah, it's all good. Cool. Lambda expressions, these are sort of like anonymous methods. We've used them in classes. We said, hey, here's a method, right? We just run this Lambda expression. You can do some other cool things with them. It gets really interesting. I think this one looks familiar, right? We've done something like this. Right? Here's a method. I'm just going to run this code, right? A one-liner, essentially. Sure, we could do that. All fine. You can specify types and arguments. That's fun. Yeah. All right. Cool. We can do files later. You okay calling it a night? I'm not feeling great. I want to go home. Is that okay? So next week, then we'll pick up. We can talk about files. You did files already, file.io. It's just easier in C#, I promise. All the same stuff works. It's just easier because their libraries are fantastic for reading lines and writing stuff and doing whatever. That's great. Operator overloading. I think you did that in 200. You can say like, what is it if my class adds another class? And how do you add these two together? You can do that. So really, like the meat here is going to be query expressions, threads, and asynchronous programming for next week, and that'll take up the whole time because it's a lot of fun. Async stuff is neat. Okay, and tonight I will try and remember to post a quiz. Maybe leave myself a note. C# because otherwise I'll forget. And then we did push out the date for the project, right? So the Texas Hold'em project, right, was going to be due in 2 more weeks then. Got a little extra time on that. So we do midterm week. I don't plan on coming because I don't care to watch you take a test. Take it anytime you want. As long as you get in by 3/9, 6 p.m., I'm okay. Take it over winter break if you want. I mean, ideally you get a break and you don't have lots of homework assigned over break, because I always hated that as a student. You're like, it's supposed to be break. I'm supposed to like actually be able to decompress and take some time off. So ideally you do it beforehand, but totally up to you folks. You can, you're adults, set your own schedule. Yeah, question?
I'm just wondering, so I understand properly. So the midterm is not, is it due the same day this time, or like,
No. So it'll open on 2/23 and the due date will be 3/9, 6 p.m.
oh,
So anytime you want to start it, stop it, come back to it, fantastic. Take your time. I mean, it's winter break, so you figure it out. What do you want to do it? Up to you. I'm good with that. And then just get the project in by midterm, 6 p.m. or so. I'll post a solution video. I think it's probably okay.
So next week is the last time we have class, week before the midterm.
Yes. So on 2/16, I'll give you last time I taught the classes midterm, because we're supposed to rewrite them every time. Because not that you folks would do it, but some folks post it to JAG or Course Hero or all those terrible websites that are awful. Which is just even posting it's a violation of our academic integrity policy. Just
I mean, I was
by the way.
even if you did do that, like, so it's like, I never saw. I mean, anytime you chose to like text solutions, because like I never actually like I have the other text I use. The problem is some of the explanations are not very good in my opinion, so I try to find more specific ones. That's what's been on. I was like, kind of write it
Yep.
down.
They don't make money off of that though, so they don't really care about that part of their business. So they don't push that. Yeah, so we'll plan not to meet on 2/23. We'll plan not to meet on break, obviously. So we'll meet next week, 2/16, and then won't come back till March 9th. That sound okay?
All right, sweet.
Awesome. No time on the midterm, Fluffy. You just open it, close it. As long as you get in by the due date, you're good. Hydration reminder. Thank you, Wolf. Sorry, I'm terrible watching chat here. Fluffy, you didn't do anything with try and finally? In CIS 200? That's really sad. All right. Well, thanks, folks. Take care. Have a good night.